Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the total solar eclipse that's coming up in April. And here to talk to us all about it is our guest, Paul Gross. Paul, welcome to the program.
Well, it's great to be here with you. How are you, Don?
Not too bad. Hope you're doing well as for yourself. Now, let's start off. If you could tell our viewers just a little bit about yourself.
Well, I was born and raised here. I've lived my entire life here, and I worked for 40 years as a meteorologist at WDIB Channel 4. And a lot of TV meteorologists across the country don't get to work at a station for 40 years, let alone their hometown station. So I've been called a bit of a unicorn by some of my colleagues, but I was born and raised here. And when I was 7 years old, I told my family I wanted to be a weatherman. And my Uncle Eddie said, "What, like Sonny Elliott at Channel 4?" And I said, "Yeah, like Sonny Elliott at Channel 4. And so went to the University of Michigan, so I never actually left home. And just, again, had a great 40-year career. I'm retired from the station now, but what I've also done for most of my career at the station also is private meteorological consulting. So I'm still doing that. So people ask, how's retirement? Well, I'm pretty busy with the consulting, but lawyers hire me, and I research weather that's important for certain kinds of lawsuits. And so that's very rewarding because I love history and I love weather. And, of course, really love this eclipse that's coming up.
Oh, for sure, for sure. It's the second one in just 7 years, so we're quite fortunate in that regard. Now, what are the two different types of eclipses?
Well, we have lunar eclipses and we have solar eclipses, and it's all about geometry. So we obviously have the sun, which is the source of light that we get. And so in the course of a lunar eclipse, what happens is the Earth passes between the moon and the sun, and the Earth's shadow is casted across the moon. So as the moon crosses through the shadow, we start to see a dark smudge appear across the moon, and then that moves across, and then that smudge gets smaller, and then it's done. Now, in the case of a solar eclipse, we reverse things, and actually we have now the moon that's passing in between the Earth and the sun. And so the moon's shadow is cast upon the Earth. And if you see it from space, and I've seen this from satellites, you actually see this smudge going across the Earth's surface. That smudge is the moon's shadow.
Interesting, interesting. So those are the dynamics, as you say, of the two different types of eclipses. Now, I understand, too, that there are a couple different types of solar eclipses. And if you could fill our viewers in on that, please.
Correct. Now, the moon's orbit around the Earth is not a circle. It's a bit of an ellipse. And that means that there are times that the moon is closer to the Earth and times that the moon is farther from the Earth. Now, before I get into the different types of solar eclipses, something that is absolutely remarkable, and it is one of the most remarkable coincidences you can imagine. Now, I want you to think about this. The sun, when we look at the sun in the sky, that disk, the solar disk, is a certain size. And when you look at the moon in the sky, like a full moon, that lunar disk in the sky is almost exactly the same diameter as the solar disk in the sky. The sun is, of course, much, much larger, but it's 93 million miles away. The moon is like 250,000 miles away, and it's much smaller than the sun, but because it's closer, it's bigger. So the size of the moon and the size of the sun in the sky are almost identical. Now, when the moon passes in front of the sun at maybe its farther distance from the Earth, the moon is just a little bit smaller, and it doesn't quite cover up the entire solar disk. So what you have is an annulus, or a ring of sunlight around the edges of the moon. That's called an annular eclipse. Now, when the moon is closer to the Earth in its orbit, it's a little bit bigger, and it covers up the entire sun, and we call that a total solar eclipse.
So there's the difference. Actually, the word annular comes from the Latin word, as I researched it, annulus, which means ring, and that's exactly what we see in that type of an eclipse. Now, with the eclipse that's coming up in April, where are we going to see totality? Where will totality be, since there's just this little smudge moving across our planet?
Yep, it's a very narrow swath, and this is really in contrast to the annular eclipse last fall, which went from the Pacific Northwest southeastward across the country. This eclipse is going to start moving across Mexico, across parts of Texas, and then curl up to the northeast. It is going to cross the Mid-South, and then it's going to pass the area of totality just south of southeast Michigan. So northern Ohio is going to get into the path of totality right through the Cleveland area and continuing to the northeast. And so what's really crazy is, because the eclipse 7 years ago, I should have said, the eclipse 7 years ago, that eclipse came from northwest to southeast. This one, southwest to northeast. Those two paths actually cross at a certain point. So there are some people in the country that are actually in the exact spot. They live in the exact spot where they saw both eclipses.
I noticed that on the maps, and those folks are pretty lucky because they only need to go out into their backyard to see two solar total eclipses.
Incredible. In 7 years.
Yeah, that's really something. So again, it's just if you're in that path of totality where you'll see the total eclipse. Now, from looking at the map there, it looks like us here in southeast Michigan and Metro Detroit, we're just outside of that path, right?
Yes, we're going to see over 95% of the sun covered, and maybe you'll notice a little bit of a dimming, assuming that we have clear skies. And we'll talk about the weather later, of course, but assuming that we can see the eclipse, and even with the clouds, you might not see the eclipse, but we should notice at least a bit of a murkiness or dimming. It's not going to get dark or dusky, but at least a dimming of the light. And there might actually be a bit of a temperature drop, not much, but in any event, we'll be able to get that much here in southeast Michigan. But to see the full totality, you would have to drive south of the state line into northern Ohio.
So what we'll see in April will be a little bit more of the sun being eclipsed than we did back in August of 2017.
That is correct, yes.
Okay, all right, so at least folks can have an idea of what to expect and, well, exactly what they can expect to see. Again, if you're in the path of totality, you get to see the total eclipse. If folks go down into Ohio, say just south of Toledo or swinging towards Cleveland, do you have a sense about how long totality will last in that particular area, or does that vary along the path?
Well, it can, and the amount of totality that we get, and when we say the word totality, that means the part of the eclipse where the moon completely covers the sun. That amount of totality, of course, is going to be factored by two things. One is obviously if you're in the center of that path line, okay, the center of the path line, you're going to get the most totality, but also how close or far the moon is from the Earth. If the moon is at, close to its closest approach, it'll be a little bit bigger, and that gives you a little extra time of totality. And conversely, if the moon's a little bit farther away, you still have a total solar eclipse, but maybe it's not quite as long because the moon's a little bit smaller. Now, I don't remember the exact number of minutes. I think it's somewhere from 4 to 5 minutes, I think. 4 to 5 minutes of totality that we'll be able to see. And those are really, I've never been in a total solar eclipse. I know many people who have, and it is something very special. It's surreal. Some people call it spiritual, but it is an incredible, incredible experience.
And that's what I've heard from a number of my friends who have also experienced one or more total solar eclipses. Is you almost can't describe it. You have to experience it. Well, this has been a great conversation so far. We have to take a quick break. If our viewers, if you have a question, please send us an email. The address is down there at the bottom of your screen. And coming up next is Term of the Month with Stephen.
Thanks, Don. The term of the month is galaxy merger. After the Big Bang, the universe was largely filled with neutral hydrogen. As stars and galaxies formed, they should have consumed this neutral hydrogen and heated it to emit Lyman alpha radiation. For years, astronomers have detected Lyman alpha radiation around the most distant galaxies. The puzzle was, why wasn't this light blocked by neutral hydrogen gas between the galaxies? Recent James Webb Space Telescope images show that these early galaxies have smaller, faint galaxies surrounding them. Computer simulations show that galaxy mergers are messy, so this hydrogen comes from these galaxy mergers. These mergers produce the larger galaxy that was originally seen and the detected Lyman alpha radiation from excited hydrogen. The radiation is local, not farther away. This mystery is therefore solved. The observations are in infrared light. The Spitzer and Hubble space telescopes were used for earlier studies. The James Webb's larger diameter mirror allows higher resolution so that the faint galaxies, smaller galaxies, can be observed. And that is the term of the month, galaxy merger. Back to you, Don.
Thanks, Stephen. We're back with our guest, Paul Gross, discussing the upcoming total solar eclipse. So, Paul, what are some of the things that people can expect to see as part of the total eclipse experience?
All right. Well, you're not going to see a lot for a while. I mean, if you're looking through eclipse glasses and things, you'll see more and more of the moon taking a chunk out of the sun as the moon starts moving across the solar disk there. But the real excitement begins as you start approaching totality. And as I mentioned last segment, maybe you're going to start noticing a bit of a fuzziness to the light. You'll notice that it's starting to just get, I don't want to call it darker yet, but it's getting a fuzzier kind of light, almost like a little bit dimmer. But the real excitement begins just as the moon is covering most of the sun, but there's still a tiny piece of the sun yet uncovered. And you see this, it's just this bright patch of light. Now, at this point, you're still looking through eclipse glasses because you can't look at the sun directly with your unaided eyes, but you'll see this bright patch, this bright sparkle of sunlight, otherwise with a dark disk. We call that the diamond ring because it looks like a diamond ring, like a sparkling diamond on a ring. So as the moon now progresses across the sun and covers that last bit of brightness, you're now going to see what's called Bailey's beads. It's going to almost be like a little string of beads. This is brief, but it's a little string of beads, it looks like. And what happens is the moon is not a perfect circle in terms of what we look at in the sky. That's what we think it is. But remember, there are mountains and craters on the moon. So what happens is when the moon covers the sun, okay, a little bit of sunlight will shine through where there is a crater because you're not, so you have, I don't know if I can do it with my hand here maybe, but you have a little crater and the sunlight is basically, the sun is being blocked by the moon, but you have a little teeny little dot of light that gets through a crater, okay, because the crater is lower, than, so in other words, you have your disk, but where there's a crater, it's lower. So you see maybe a little string of beads. Those are called Bailey's beads. So as the moon then progresses across the solar disk, as you get to the other side now, you'll start to see some Bailey's beads. And then you quickly transition to that diamond ring. And then quickly you're in bright light again. But if you're looking through eclipse glasses, you're going to see now just a small chunk of the sun taken out by the moon that then gets bigger and bigger and bigger. So it's not just the matter of, hey, when we're at totality and the moon covers the sun, it's dark and things like that. It's more than that. It's the progression to that with the diamond ring and then Bailey's beads, then totality, then Bailey's beads, and then the diamond ring again, and then back to light.
Interesting. Now, I also understand that nature takes notice of the total eclipse. Can you talk a bit about that?
Well, sure, because as it gets dark during the time of the eclipse itself, I mean, birds are fooled. Birds start basically roosting, so they think night has suddenly fallen on them. And sometimes you hear like certain insects and frogs and things that you hear at night. All of a sudden, you might start hearing them make noise because, again, they think it's night. And as far as an environmental factor, you actually do get a little temperature drop briefly during the eclipse because, listen, you're blocking the sunlight. What gives us our heat? The sun. So anybody who has a weather station at home that measures temperatures, you should actually chart like every minute through the eclipse or have somebody do it for you. Every minute through the eclipse, chart the temperatures. You'll notice the temperature will drop a bit during the eclipse and then start rising again after the eclipse ends.
Interesting, especially the reaction to the darkness by nature, which really only lasts about 4 or 5 minutes, but obviously they're very, very attuned to that. So we've talked about nature and the types of things that we can see just preceding totality and immediately just after it. But one big thing, the elephant in the room, so to speak, is the weather. And how does that affect viewing?
Well, obviously, cloud cover affects viewing, and so it can really be kind of dicey. I remember there was a total solar eclipse in Europe about, I want to say 10 or 15 years ago, I think it was. I may be a little longer. And a close friend of mine was a TV meteorologist in the Netherlands. She was out with a camera crew chasing the eclipse, and all of a sudden clouds moved overhead. So they started just driving any which way, and they got a small bit of a thinning of the clouds or a break, and they were able to see it briefly. And then it clouded over again. So that kind of ruined the experience for them. So the key is that we want clear skies. Now in April, we still have storms that are crossing the country. We have certain storms that go up the East Coast, and sometimes you can even get a nor'easter in April. And we sometimes have those storms that develop on the lee side of the Rockies. They kind of dip down from Colorado, New Mexico, down into Texas and kind of hook up to the northeast. So we have those. And then we have those Alberta clippers that form in the Canadian province of Alberta in the northwest. Those kind of zip down to the southeast across the Great Lakes and then kind of curl back up. And so those are usually quick movers. So there are any different number of kinds of storms, that the storm systems I'm talking about, that can give us cloud cover. So where are the best odds? Well, as you get into the west half of Texas, those are the best odds for getting sunshine and clear sky. And then as you keep heading northeast, you start getting into better chances for cloud cover. But that doesn't mean it can't be clear here and cloudy down there. It just depends upon what type of weather pattern and what kind of storm system we're looking at. If we have one of those Colorado storms that forms on the lee side of the Rockies, and that's affecting Texas and perhaps Oklahoma and Arkansas and that area down there, they could be cloudy. And if we have high pressure up here, we could be sunny. But in terms of the odds, climatology, which is, again, climatology is an average of long-term weather. So as the old saying goes, climate is what you expect, weather is what you get. And so the odds are that there are better chances for sunshine the farther southwest, especially into West Texas, that you go. And the better chance for cloud cover is up here in the northeast, but that doesn't mean it can't be reversed on eclipse day.
Exactly. It's the luck of the draw, I guess. Now, we touched on it for just a moment, but I think it's something that really bears repeating and really getting into, and that is safe viewing.
Yeah. Now, people that have telescopes, they know that you don't look at the sun without a proper filter. So I'm not really reaching out to you folks that have telescopes. You know that drill. It's the average member of the public that thinks that you can just look at the sun and watch this whole thing happen. Well, the sun's rays are very, very intense. Okay. And if you look at the sun for just a short period of time with no eye protection, you're going to burn your retina. And it shocks me, but it happens every time there's a solar eclipse, a total solar eclipse. I hear a report somewhere of somebody who suffered permanent eye damage, permanent eyesight loss, because they looked at the eclipse without the eye protection. So now for me, I got these from NASA at a conference, but I have my eclipse glasses here. And anybody, you can go online and buy these things. You can go online and they're not expensive. You can go online and buy eclipse glasses and buy them for your whole family, buy them for friends, whatever. But you need to use that eye protection. It is very important. You just put those things on. You can watch the sun. You can watch the whole progression of the moon across the surface. Now, the one time that you don't need the eye protection is during totality. When the moon has completely eclipsed the sun and you have no intense solar rays coming through, you can take off the eclipse glasses and just take it all in. And with the naked eye. And that's what you want to do. You want to experience that. And so that's the great thing. And by the way, a lot of people, and I see it at sporting events all the time, people just, all they're doing is through their phone, just watching through their phone and recording and things like that. You know what? Maybe take a picture, a quick video, whatever you want to do, but do not miss the opportunity to just take a minute and just look up and just enjoy this with your own eyes and just have a memory of just looking at this thing. It is a surreal, wonderful thing to experience.
This is what I've heard from a number of my astronomy friends who have seen them, and folks who, image. They say for the first one, just watch it. There'll be images all over the internet that you can download for future reference. Now, we've only got a couple of minutes left, Paul, in our program. So what else do we want to fill in our viewers about?
Just one thing real quick. There are going to be a lot of people traveling for this eclipse, people on the roadways, and people are going to stop along the roadways and watch. So one, be careful, be safe on that regard. And two, just, and I have a friend who's actually kind of leading this effort. Pick up after yourself. Don't leave garbage along the sides of the roads and at your campsites and places where you're going to watch this eclipse. So, be respectful of the environment around you and pick up all your trash, the stuff, the garbage that you have. And one last thing, people are asking me, what am I going to be doing for the eclipse? Well, what I've got is a plan. So I have some friends that are going to be going to West Texas to watch, and I got to talk to them about maybe flying there to watch. But I have relatives in Cleveland, which is right in the path of totality. So I'm going to have a plane ticket purchased, and I already have the plans made with the cousins in Cleveland. And basically, if it's going to be clear up here, I'm just going to drive to Cleveland and use that plane ticket another time. But if it's going to be cloudy up here, I'll fly down to Texas.
Sounds like a good plan. I've been invited to a cousin's house in Rochester, New York. And again, on the path of totality, but again, we're sort of rolling the dice with being able to get some clear skies. Paul, I want to thank you so much for taking the time out of your schedule to talk to us about this exciting eclipse coming up here in the U.S. For the folks viewing, please check out our club website. The address is down there at the bottom of your screen. And to finish out this program, as always, is What's Up in the Night Sky with Stephen.
Thanks, Don. What's up in the night sky for February 2024? The days are getting longer in the north and shorter in the south, and this process accelerates until we get to the equinox. February starts with a last quarter on the 2nd, a new moon on the 9th, a first quarter on the 16th, and a full moon on the 24th. Shown here on the 1st of February is Mercury, Mars, and Venus, just before sunrise. Mercury goes from Sagittarius to Aquarius over the month, and it rises at sunrise, an hour before sunrise, but at the end of the month we have superior conjunction, specifically on the 28th of February. So it's best at the beginning of the month, and not just because Mercury has aphelion, that's when it's farthest from the sun physically, on the 2nd. Now Venus goes from Sagittarius to Capricornus and rises 2 hours before sunrise to an hour before sunrise, and is therefore best at the beginning of the month. Mars goes from Sagittarius to Capricornus as well, and rises 2 hours before sunrise, but at the end of the month, it rises at sunrise. Then we have Uranus, Jupiter, Neptune, and Saturn shown here again on the 1st of February, but just after sunset. Jupiter is in Aries and sets from 7 hours after sunset to 5 hours after sunset over the month. Saturn is in Aquarius and sets from 2 hours after sunset to sunset. Superior conjunction is on the 28th, just like Mercury for Saturn. Uranus is in Aries and sets 8 hours after sunset to 6 hours after sunset. It also goes from magnitude 5.7 to 5.8 over the course of the month, and so should be visible naked eye. It should be far enough away from the sun to make that happen. Wait long enough after sunset. Neptune is in Pisces and sets 2 hours after sunset to basically sunset at the end of the month. So it's best at the beginning of the month. It's magnitude 8, so you need binoculars to see it. Superior conjunction is coming up in March on the 17th, March 17th. Now, Pluto is in Capricornus, and it rises from about sunrise to 2 hours before sunrise at the end of the month, but it's really not very far from the sun, and you'll be using a fairly large telescope, at least 10 inches, if not 12, to see it at all. Its magnitude 14.5. It'll be a little brighter in June or July when it's also in a better position. And that is what's up in the night sky for February 2024. Remember, we don't charge money for this show, but we may tax your brain.